Liftoff at 9:34 a.m. Eastern Daylight Time.
The U.S. space program. It spawned an enormous research and development effort, which yielded a vast array of commercial opportunities. Miniaturized components, new methods for generating electricity, and a new kind of fluid that was actually magnetic.
The idea was to take a rocket fuel in a liquid state and impart magnetic qualities to it. Thus, in a zero-gravitational environment, you could magnetically manipulate the rocket fuel, hence the evolution of ferrofluids. For the first time in history, a magnetic force could be exerted on a fluid to control its position. This places a brand new technology at society's disposal with broad and far-reaching implications.
What could be done with this fantastic material? One of the engineers who worked with NASA, Dr. Ron Moskowitz, decided to find out. Taking the word ferrofluids, he formed a new company called, logically, Ferrofluidics in 1968 to develop the commercial potential. Basically, ferrofluids are composed of magnetic particles less than 100 angstroms in size and coated with a stabilizing agent. These particles are then dispersed in a low vapor pressure synthetic lubricating carrier oil. The result? An ultra-stable fluid that responds to a magnetic field. When a magnet is applied, the ferrofluid can be precisely positioned and controlled.
But suddenly there was an opportunity to have force much greater than that of gravity. We could make rivers flow upstream. We could make coffee stay in the cup if it were turned upside down. And the possibilities were limitless. Hydraulics, lubrication, wherever fluids were used.
It is mandatory that computer disk drives seal out external contaminants. Even minute particles can cause loss of data or, disastrously, system failure. A conventional mechanical seal in the disk drive will inevitably have very small areas where the seal material does not meet the surface of the mating part, resulting in leakage.
But if you have a liquid O-ring, like that of a ferrofluid, when it is used in a magnetic field, it completely seals the surface.
In fact, the ferrofluid does assume the shape of a liquid O-ring to completely fill the gap and provide an hermetic barrier. And because these same seals are liquid rather than elastomeric, they're non-wearing. These kinds of rotary exclusion seals are also used in optical scanning devices, high-speed laser printers, rinser dryers, and actuator systems. Ferrofluid seal subsystems are designed for use in semiconductor manufacturing, where vacuum processing is essential and leaks intolerable. Ferrofluidic products make that possible.
The fact that you get virtually no wear on the seal and it lasts essentially forever. You can design a ferrofluidic seal into a system and not have to worry about maintaining it or going back to replace it on a scheduled basis.
Other uses of ferrofluids in this marketplace include a variety of process applications, such as ion implantation, plasma etch, sputtering, and chemical vapor deposition. Other product applications include X-ray generators, lasers, lamp bulb manufacturing, fiber optics manufacturing, sterilization chambers for the biomedical field, and hydrocarbon emissions containment seals for petrochemical processing.
Environmental trends and regulations and legislation have created opportunities for us that didn't exist actually 20-some-odd years ago. They were maybe talked about or on the horizon, but they didn't really exist.
Ferrofluid seals are used in one of Ferrofluidics' own product lines, crystal growing systems. The crystal growing process for semiconductor crystals must be conducted in an environment that excludes reactive gases such as oxygen and water vapor. In addition, rotating components must not allow vibrations into the system, which can cause loss of the desired crystal structure. This schematic indicates the location of ferrofluidic rotary feed-through seals, which ensure an hermetic seal necessary to achieve proper crystal growth. Ferrofluidics' crystal growing system is fully automated, from the initial pump down and melt of the solid material through the initial seeding process to the growth of the crystal. A video scanning system is used to automatically control the diameter of the resulting crystal ingot.
Ferrofluidics entered into the systems equipment business whenever they saw the possibility of the application of their rotary vacuum feed-throughs for the reduced maintenance and the improved product quality enhancements that they brought into the crystal growing business.
Besides producing materials for silicon chip manufacture, the ferrofluidic system can be used to produce gallium arsenide for use in LEDs, monolithic microwave integrated circuits, and hybrid circuits. Other products manufactured include germanium, sapphire oxide, and metal for high-strength turbine blades.
We are already looking at the technologies which will come in 2 to 3 years from now, and that is a very satisfying thing for us. Not only we have got the business to serve our current technology, but we are already preparing ourselves to serve our customers' future needs.
One of the inherent attributes of fluids is their ability to dissipate heat. Because the magnetic properties allow the fluid to be contained, the material is able to transfer heat away from dynamic voice coils. This attribute made ferrofluids ideal for use in loudspeakers.
The fact that you have a ferrofluid in the gap removing heat off of the voice coil and transferring that heat through the additional metallic mass in the structure here.
These are two identical speakers, one on the left with ferrofluids and one on the right without. A thermocouple will indicate the temperature of the voice coil as equal current is applied. It can easily be observed that the temperature on the speaker without ferrofluids rises very rapidly, whereas the one with ferrofluids exhibits a very small increase. At first, ferrofluids were limited to tweeters, but new technology has changed that.
As we got into specific applications, suddenly there were requirements to meet a certain temperature range, a requirement to meet a certain rotary speed, a requirement to meet a certain shaft diameter, and a whole set of physical and chemical requirements for given applications. In order to meet those, that meant literally designing the ferrofluids to meet the requirements of the applications and the markets.
And so Ferrofluidics developed new fluid carriers of the magnetic material, which now make it possible to use ferrofluids in woofers. These are also used in automotive speakers for very demanding customers, such as Mercedes-Benz, Porsche, and BMW, because of the power handling characteristics. The ability to position and control fluids found another logical application: bearings. The standard ball bearing utilizes a complement of small metal balls in between two rotating elements. The bearing, by its very nature, and no matter how precisely it is constructed, will always have non-uniform balls and slightly out-of-round raceways, which will cause the rotational motion to change unpredictably from one spindle revolution to the next. This leads to what is known as non-repeatable runout. Ferrofluid film bearing spindles operate under the physical laws governing hydrodynamic lubrication. As the speed of the rotating element increases, pressures are generated which separate the shaft from the housing by a fluid film. The result is not only great accuracy, but with the elimination of metal-to-metal contact, low noise characteristics, and long operational life. In addition, the presence of the ferrofluid itself provides a viscosity that diminishes friction and limits heat generation.
The technology advantages are that because there's no metal-to-metal contact like you would have in a ball bearing spindle, the non-repeatable or random wobble is essentially zero. So it finds applications in any area that requires high precision rotary motion, such as disk drives, machine tool applications, or laser scanner applications.
Clearly, these characteristics are of tremendous advantage in the computer disk drive industry. In fact, ferrofluid bearings dramatically reduce track misregistration in disk files. 20 years ago, when Moskowitz and others began Ferrofluidics, the need for the product was limited.
Now, the components of the ferrofluid itself have major application, for example, as microparticles in medical systems.
There's a variety of applications going on in the biotechnology area, and it's an explosive area, and we plan on participating in that area quite a bit going forward.
We're seeing enormous expansion in all of our respective areas, and we expect this growth to accelerate. So with that, in fact, here we are 22 years later, and it's been clear that we did in fact start an industry, and that's, but even at this stage, it's the beginning of this industry. There's many exciting things to come.
Ferrofluidics, born of the space age, ready to lead us to the future.